This is Pet Life Radio. Let's talk pets.
Welcome to Aquariumania. I'm your host, Dr. Roy Anon, speaking to you from the University of Florida IFAS Tropical Aquaculture Laboratory. Thanks for joining us. Jacques Cousteau introduced many of us to a place both alien and beautiful, the underwater world. Decades later, our oceans and marine ecosystems have gone through significant changes. So what's happening down there? My guest today, Dr. Robbie Lamb, faculty at the University of Florida's School of Forest, Fisheries, and Geomatics Sciences and the Nature Coast Biological Station, is determined to answer that question. Robbie's work in the Caribbean, South America, and the U.S. helps explain how marine communities respond to this changing world. Robbie's and his colleagues' research has been highlighted by National Geographic and most recently PBS. Oh, and he used to be a professional basketball player in Ecuador. Join us as Robbie shares his journey and insights. We'll be right back after these messages.
Take a bite out of your competition. Advertise your business with an ad in Pet Life Radio podcasts and radio shows. There is no other pet-related media that is as large and reaches more pet parents and pet lovers than Pet Life Radio. With over 7 million monthly listeners, Pet Life Radio podcasts are available on all major podcast platforms, and our live radio stream goes out to over 250 million subscribers on iHeartRadio, Odyssey, TuneIn, and other streaming apps. For more information on how you can advertise on the #1 pet podcast and radio network, visit PetLifeRadio.com/advertise today.
Let's Talk Pets on PetLifeRadio.com.
Welcome back to Aquariumania on Pet Life Radio. My guest today is Dr. Robbie Lamb, marine ecologist and research scientist based at the University of Florida's School of Forest, Fisheries, and Geomatics Sciences and the Nature Coast Biological Station. Oh, and he's also on Nat Geo and PBS Star, but we'll talk about that later. Thanks for your time, Robbie.
Thanks for having me, Roy. It's a pleasure.
So with a lot of my guests, I like to kind of get a little personal early on, get a little feel for what kind of drove them into doing what they do, and who were some of your childhood influences that got you interested in nature and marine life. And I have to ask, of course, did you ever have an aquarium?
I absolutely had an aquarium. We had a freshwater aquarium as I was growing up. I don't remember exactly what kinds of fish we had, but we had a couple different fish and some freshwater salamanders as well, as I recall. So that was definitely something that I spent long hours looking at when I was real small. But I guess my first inspiration for being a biologist came from my mother, who was an avid bird watcher, and that was something that she picked up from her grandfather, or from her father, my grandfather. So this was really kind of a family tradition at that point. And so she would get me up at 4:35 in the morning, and I would be rubbing sleep out of my eyes, but also pulling on these binoculars and getting really excited about seeing a red-tailed hawk or a bald eagle. And so that kind of honed my observation of wildlife and nature, and got me interested in just seeing the diversity of life that is out there in the world. And that kind of combined with watching Jacques Cousteau documentaries as a child, and David Attenborough and crocodile hunter shows and things like that about the wild places that had still so much left to be explored and discovered. And that sense of being able to observe wildlife, observe nature, and be able to do scientific discovery was really kind of what drew me into this field.
So were there any high school experiences that were pretty impactful for you, both either life-wise or career-wise?
Absolutely. I have to say that for all those parents out there that are thinking about their kids and what they want their kids to be able to do and experience in life, I think that when you're in high school, you're in this very sensitive, fragile time when there's a lot of opportunity to grow and expand your horizons. And my mother, again, I keep coming back to her, but she was fundamental in exposing me to some new opportunities that hadn't even crossed my mind as possibilities at the time, but she came across them and kind of fed them my way and opened my eyes to a lot of possibilities. So one of them was there was a scuba diving training and sort of marine science field course in the Caribbean in the U.S. Virgin Islands that you had to pay quite a bit for at the time. I think it was like $2,500. It was a lot of money. It was more than I could, make myself as a high school student working. And so my mother was able to get a scholarship or help me get a scholarship for this course. And I went down for 4 weeks of learning how to scuba dive and learning how to be sort of a coral reef, not biologist yet, but certainly someone who appreciates it and was able to, identify species of coral reef fish and start thinking about how these ecosystems are put together. And so that was really my first experience of working underwater, seeing things with my own eyes. When you see the surface of the water, it's easy to think that there's not a lot of life out there because it's just this blank canvas. But once you put on a mask and you dip your head under the surface and you see what's truly out there, it's just this rich world of colors and shapes and swirling particles of water and fish and algae, and it's just the most beautiful tapestry of life. So the second that I did that, I was hooked forever. Like at that point, I knew I was going to become a marine biologist. The other thing that I'd like to thank my mother for is that she didn't send me, but she encouraged me to go on exchange as a high school student. So I went to Ecuador for a year in my junior year of high school as a Rotary exchange student. I lived with two different host families over the course of that year, became very integrated into those families. I learned Spanish. I did a lot of volunteer work in the town that I lived in, which was Puerto Viejo, a very not that small, but kind of isolated town, doesn't have a lot of tourists visiting or anything like that. So it was a real immersive experience and just a very rewarding, life-changing experience that, again, my mother really encouraged me to do. And that really kind of opened my mind to some of the uh, international context of the world that we live in, this global society that we live in. I think that the exchange programs like the Rotary one are really fundamental for generating world peace because they show you how somebody else lives and kind of open your mind to other possibilities. And once we open our mind to those different possibilities, we become that much less biased and closed-minded to other cultures and other ways of seeing the world. So those two experiences really kind of shaped who I became afterwards, which is, I guess, an international marine biologist.
Yeah, those both sounded incredible. Would have definitely would have loved to do that. So let's talk a little bit, fast forward a bit, and talk a little bit about college and experiences after. What did you end up studying in college, and did you have any experiences during your undergrad that most influenced you?
So I was a biology major. I went to Oregon State University, go Beavers, one of the fiercest mascots in the country. But it was a fantastic school. It was a state school, state university, and much like the University of Florida, where I am now, it's a land grant university. It's actually I think there's only one other university. It's both a land grant, a sea grant, and a space grant. So they do a lot of really high level research across the board. And I got involved very early on with the lab of Dr. Mark Hickson, who's a pretty well-known coral reef ecologist. He's now at the University of Hawaii, but at the time he was at Oregon State. And as a freshman, we had a seminar series where they would bring in biologists of different fields, people that had gone through biology as an undergrad and then gone into different fields of science or industry, medicine. We had, a doctor come, we had a nurse come and give a talk. And so each week somebody would come from different fields of biology and give a talk about what it's like to be in their career path and how they got there from being an undergraduate biology major. So one of those talks was by Dr. Hickson, and he was a professor at Oregon State, like I said. So he gave his talk, and I went up to him at the end of the talk, and I said, "Hello, my name is Robbie. I want to do what you do. Maybe you'd have some opportunities for me working in your lab or something like that so that I can kind of learn how this path might unfold." And he was really gracious and opened, space in his lab for me to come work. What I started doing was they had this really interesting experiment that they were working with these territorial damselfish. So damselfish lay eggs on the seafloor, and they guard those eggs really viciously from potential egg predators. But they also guard the territories where those eggs are laid. And those territories are sort of an indicator to potential mates of the strength of territoriality of the fish. You know, if I'm able to protect this garden really well from potential herbivores or other things that would want to eat what's there, I'm also really going to be good at protecting your eggs. So they took advantage of the fact that these guys like to lay eggs on sheltered surfaces. They would put these PVC tubes out underwater and line them with an acetate sheet, like an old projector slide kind of sheet. Then when the fish lay the eggs on the inside of the tube, they could pull that acetate sheet out and lay it out into a two-dimensional egg patch, in which are, eggs are laid in sort of one layer. And so by calculating the area of that egg patch, we could then figure out what the fecundity or reproductive output of those fish was. So I first started off in this lab reading these digital images and calculating area, and then dividing that by the area, the circumference of a single egg, and you would get the total number of eggs or reproductive output. And that's really fundamental information for studying things like fisheries biology and population genetics. So he opened up a space in his lab doing this sort of not menial work, but certainly it's not out scuba diving on a coral reef, but still it was working in this field and opening up a chance to see what that research was really like. And that's actually a model that I've kind of taken on as a professor at University of Florida myself, is that you give students the opportunity to kind of show their worth and their interest level with one of these sort of data processing type of jobs. Once I was kind of doing well in that and showing my my motivation and dedication to that work, Dr. Hickson allowed me to start looking into ways of funding my own way to go to the Bahamas, which is where he was doing his field work each summer. And so I obtained a couple of undergraduate research fellowships. And for those of you who are undergraduates currently, or who have kids that are undergraduate students in universities, look out for these research fellowships, because they often open a lot of doors in terms of field opportunities for research with professors that otherwise don't have the funds to bring you with them. And so that's how I kind of paid my way to the Bahamas and was able to do my own undergraduate research with Dr. Hickson. And so out in the Bahamas, this was basically working for 3 months straight, every single day under the water for 4 to 8 hours. It was a dream. It was like I finally felt like this is what life is all about. It was so great. And obviously challenging work as well. You're wet, you're tired, you're cold throughout most of the day, but really rewarding work, because I got to be, a part of these coral reef ecosystems and see them from the bottom up. I was able to publish an undergraduate thesis project as a result of that work, and learned sort of the basics of what it takes to do underwater research, which is a whole field unto itself.
Well, that definitely prepped you for what you're doing. Now we have to do a really minor break and talk about some Robbie Lamb trivia. So can you very briefly kind of tell us how you became a basketball star in Ecuador?
So basketball is not the most popular sport in Ecuador, not by a long shot. But when I moved down there in 2004, 2008, I'm sorry, when I finished college, I had been playing basketball at Oregon State as part of the practice squad that would practice against the main team, the varsity team, and give them sort of a sparring partner, so to speak. So I was a decent basketball player, but I didn't even make my own high school varsity basketball team. I wasn't good enough. But when I moved down to Ecuador, suddenly I was like the tallest guy on the court, and I could handle the ball a little bit. So very quickly I got roped into this professional basketball league in Ecuador. And so we would travel by bus to different cities each weekend and play in these tournaments and sign autographs and all this stuff. I never made any money out of it. It was pretty much enough to pay your bus fare, but it was still a lot of fun. And a little side note away from marine biology.
That's awesome. So let's talk graduate studies now. What made you decide to go to graduate school, and where did you go?
So I didn't have probably the most typical progression from undergraduate to graduate school, but I always had a graduate school on my horizon. I always knew that was something that I wanted to pursue, because from the get-go, I was attracted to a lifetime of study and learning about the ocean. It really was more than a job for me. It was a passion. It was something that I knew that I was always going to want to pursue. And so following a graduate program of research in marine science allows you to design a job around that pursuit. And I always knew that that was going to be the thing for me. But when I graduated college, I actually started off with a Fulbright fellowship to go back to Ecuador, where I had worked and lived before. And I started working in fisheries sustainability and the development of rural fisheries in coastal Ecuador. So a Fulbright grant, this is another fellowship opportunity for those of you out there interested. Take a good look at this one. They're available not just for recent postgraduates from college, but for professionals of all ages. So these Fulbright grants are very similar to a year-long exchange program in that you go to another country and you really immerse yourself in that country's culture. You learn the local language. You usually work with a local partner to develop some kind of research project. So right after college, I received one of these grants to go to Ecuador and work with a series of small fishing villages along the coast of the northern province of Esmeraldas in Ecuador to develop sustainable fishing practices and to try to get these fisheries certified under international sustainable fisheries paradigms, which would allow them to export their fish at a higher value per fish and also improve the sustainability of the fishery. And so I would go out with these guys swordfish fishing. We would go out for 3 or 4 days at a time in a 15-foot open fiberglass boat up to 100 miles offshore. It was really harsh conditions, exposed to this tropical sunlight, the wind, the waves, 24/7. At night, we would sleep in the basin of the boat, the bottom of the boat, with fish guts and squid kind of sloshing around us. So it was really quite something to see how these people live and how they make a living off of the sea. But it was a really eye-opening experience for another reason, which was that after a year of heavily investing in these communities, we did make a lot of progress, but at the same time, there were outside influences that were undermining our ability to make progress. Merchants that saw our efforts, which would divert the production of these fisheries into an international export, they started to undermine our relationship with the community by spreading lies about embezzlement and things like this. And so our connections with those communities were really maligned by that type of um, lies, basically. And the problem with these types of issues is that when you try to generate a new economic model, if you leave people out of it, they are going to find ways to undermine that new economic model. And we hadn't taken into account the local merchants that were going to be losing their livelihoods essentially because of this new product export idea that we had. So that really kind of shifted my focus back towards biology. I got the sense that working with humans was too challenging for me. These are fickle beings that will, say one thing today and say something completely different the next. And so really my pursuit and my attraction to biology is that there's a natural world out there that operates under relatively fixed rules, and it's up to us to kind of learn and understand what those rules are, but they are reliable over time. Whereas with humans, there's just this whole other dimension that comes into it. So I really enjoy sort of the hard and fast nature of biology, I suppose, as a result of that.
Deciding to go and where you ended up going for grad school?
Yes, sorry, got sidetracked a bit. So that experience of going on a Fulbright year kind of set my course back towards empirical science. So I decided that I wanted to get a graduate degree in marine ecology. And first, I did that as through a master's program. So I got a master's degree at the Universidad San Francisco de Quito, which is a university in Quito, Ecuador. I was looking at biogeography of intertidal communities along the coastline of Ecuador, because Ecuador is at the confluence of warm water coming down from the north, from sort of the around the coast of Panama and Colombia, and colder water coming up from the south along the coast of Chile and Peru. So those two warm and cold water currents mix around the coastline of Ecuador. And so I was really interested in seeing how intertidal ecological communities varied with proximity to these cold and warm water currents. While I was doing my master's degree, I sort of just by happenstance met the person who would end up being my PhD advisor, who was John Whitman. John was a university professor at Brown University, where he still is currently. And at the time, he was doing research in the Galapagos at the same time that I just happened to be there. And so I got to meet John and go diving with him a couple of days, and saw what his field operation looked like. And I was just immediately hooked. I thought this is for me. The Galapagos Islands are obviously this incredible place full of marine diversity, one of the most productive marine ecosystems on the planet. And here was this really well-renowned professor that was doing high-level work there. It seemed like the perfect marriage of my passions, which was Ecuador and marine ecology. So I wrote to John and said, "Hey, I'm looking for a graduate program." He said, "I'm looking for a graduate student," and it just kind of worked out that way.
That's awesome. So actually, I had one more quick question before we take a break. We're going to talk more about some of your work with John, but were there any real valuable lessons, or what would you consider some of the most valuable lessons you got from John?
Oh man, John Whitman is a class act. Let me tell you, he is one of the most positive, um, hardworking, and personable scientists that you will ever meet in your life. From the day that I met him, John has always had a smile on his face. And this doesn't matter if it's raining or shining outside. One of the first and strongest lessons that I learned from John was about keeping a positive attitude and seeking out an answer and a way of solving things, even in the face of uh, calamitous circumstances. So the very first summer that I spent in the Galapagos with John, I was helping out on an experiment that they had running where they were filming interactions between fish, urchins, and algae over the full daylight and nighttime period, so 24 hours a day. And so they were filming this using time-lapse camera systems, and then at night, those time-lapse camera systems had an external flash that would light up the scene. And so these experiments were intended to test a trophic cascade, which is the idea that if you change the abundance of top predators, that change in top predator abundance will change the abundance of herbivores, and that change in herbivore abundance will change the abundance of plants. And this is a well-known paradigm in ecological theory, but it's been rarely tested underwater. So they had this great experimental setup looking at predators of urchins, so fish that would eat urchins, urchins which eat algae, and all lit up with this custom-made, like $200,000 video system for underwater filming. And the very first night that we set this all up, it was probably 6 hours of consecutive dives trying to get this all set up perfectly on tripods, filming the whole scene, making sure the flashes were working. And we pressed record and saw the little red light blinking away. And we went back up to the surface and had dinner and a good night's sleep, thinking that we had this great experiment rolling. The next day, we dove back down, pulled up the system, opened up the canister to download the video files, and it was full of water. The whole thing had flooded overnight. And the problem was that we had, a canister that was housing the battery and the memory cards for the video. And that had these hoses that were connected to the lights and the cameras. And at each of those hose to compartment connections, there were weak points. And with the waves and the motion in the ocean, all of that caused it to leak. So this was, years of and hundreds of thousands of dollars of investment up to this point. And what did John do? Well, he looked in there, he said one F word expletive, and then he said, well, we're just going to get GoPros out and we'll film it during the day and we'll continue forward with the experiment and we'll just not worry about the nighttime stuff. And he did it, and he got an ecology paper out of it, which is a really high level journal in our field. So that lesson to, keep your head up and not take no for an answer when life is going to give you lemons, you got to figure out a way to make lemonade. And in science, in particular in field science, you often have these issues arise. Things don't work the way they're supposed to. Natural elements break things all the time. And just keeping focus on your goal, which is answering that scientific question and not allowing those types of setbacks to really change your focus, you can come up with a really good solution at the end. And that was a really fundamental lesson that I got from John.
Awesome. And yeah, for our listeners, I did have an opportunity to work with Robbie, and I see where a lot of his coolness in the face of our adversities came from now. So I appreciate that, Robbie. So let's take a short break, and we'll continue our discussion with University of Florida marine ecologist and Galapagos expert Robbie Lamb after a word from our sponsors.
Begging to hear more of your favorite show? Full episodes of all our shows are available on demand. Go to PetLifeRadio.com to fetch our entire lineup of Possum Pet podcasts. Also, dig us up in iHeartRadio and iTunes. Let's talk pets. Live and on demand, only from Pet Life Radio.
Let's talk pets.
Let's talk pets
On Pet Life Radio.
Pet Life Radio.
PetLifeRadio.com.
We're back and continuing our conversation with my guest, Dr. Robbie Lamb, marine ecologist and research scientist at the University of Florida. So, Robbie, we talked a little bit about your background and how you got a can-do, positive attitude that I was able to witness often. Let's talk a little bit about your research and your current research and maybe some of the past. Can you explain in general, I guess, what questions you are trying to answer? I know there's many different questions, but maybe kind of as like a whole, what sort of things are you trying to look at? And we'll talk more specifics later.
Yeah, so I think pretty much all of my research can be summed up as trying to understand how environmental change is affecting marine life on our planet. And so I look at a variety of types of environmental change, but for the most part, we're looking at temperature change, which is really the largest, most fundamental change that humans are exacting upon our planet, which is climate change via the increase in carbon dioxide concentrations in the atmosphere. And so the warming of the Earth's atmosphere, and by virtue of that, the warming of the Earth's oceans, is expected to have all kinds of ramifications. And I've been trying to test some of those predictions of how things might change using either natural variation in temperature that exists in geographic or temporal change of temperature over time, and also doing experiments both in the laboratory and underwater that try to test the mechanisms that explain why things change when temperature or other types of environmental change occur. So a couple of examples of this we're looking right now at how food webs are affected by temperature change in the Galapagos Islands. So temperature increases in the ocean tend to stratify the surface waters. And what I mean by stratification is you get a lens of really warm water that sits on the surface of the ocean, and that warm water lens usually has very little nutrients and life in it, especially in the tropics. So we all know that plants need nutrients to grow, right? If there isn't a lot of mixing of the surface waters, that means that the plants that are living up in the very shallowest band of the ocean utilize the nutrients that are there. Then they either get eaten or they die. And when they leave the ecosystem because they've been consumed or they sink, there's very little nutrients to replenish what they've consumed. So temperature increases in the ocean are expected to increase that stratification of the surface waters and reduce the amount of nutrients available for photosynthesis. So in the Galapagos Islands, there is a natural spatial gradient in temperature of about 3 degrees centigrade. And 3 degrees might not sound like a whole lot, but the ocean is an incredible buffer of temperature change. It takes a lot of energy to change water, even 1 degree centigrade. And the oceans are enormous. So it takes a lot of heat to change the oceans by 1 degree centigrade. And also, most of the organisms that live in the oceans are ectothermic. That means that their body temperature mirrors the temperature of the waters in which they find themselves. And so unlike a human, which can go from the Arctic all the way to the equator and not feel too terribly put out by that fact, you might have to take off a few jackets, but humans are able to modulate our temperatures regardless of the external temperature. A fish doing that same migration would suffer a huge physiological change because the rate of metabolic processes is directly scaled to temperature. And so, if this warming continues to progress as we've seen it progress already, there is this expectation that the surface oceans will become impoverished of nutrients, and that will reduce the amount of primary production and energy available to flow through food webs and generate biomass at higher levels for things like seabirds and sharks and so on. So we're using this natural spatial gradient in temperature and also temporal change in temperature, because there are years when the waters are really warm in the Galapagos. Those tend to be El Nino years, and there are warm years where the waters tend to be very cold, which are the La Nina years. And so we have this temporal change in temperature and a spatial gradient in temperature, and we're using both of those to examine how food webs change when the oceans warm up.
So I guess talking a little bit more about the Galapagos, you had some kind of interesting findings when you were there, I guess 2016 or 2017. You want to talk a little bit about maybe some of the things that you see that appear to be temperature related, El Nino related?
Absolutely. So I mentioned this El Nino effect. So El Nino occurs when the trade winds, which are normally blowing constantly from east to west, those slow down during El Nino years. And the fact of those winds slowing down causes the surface currents that those winds are constantly blowing westward to also slow down. When that happens, the upwelling of cold, nutrient-rich water to the surface stops. It's like a conveyor belt that's driven by these trade winds. And so when the trade winds stop, that conveyor belt also stops. And the Galapagos are located at the epicenter of El Nino phenomenon in the ocean, which is this eastern tropical Pacific area right off the coast of Ecuador. And where the Galapagos are located, an El Nino event signifies substantial warming of the surface waters of the ocean, anywhere from 1.5 to 3.5 degrees centigrade, and that can last for about 6 to 12 months. So I mentioned that most organisms in the ocean are ectothermic. That means that their body temperature changes with the temperature around them. So there's two things that happen during temperature increases in the ocean. One is that the metabolic rates of microorganisms, things like bacteria and viruses, speeds up a lot. Their metabolism is also linked to temperature. And so those microorganisms suddenly are able to reproduce a lot faster, and they become more pathogenic. That means that they incite and cause disease at a much faster rate than in colder normal temperatures. The other thing that happens, as I mentioned, is that the fish and other organisms that are consuming, that are out there trying to forage and feed in the water, they are also speeding up their metabolic rates because of warmer temperatures. So they need more food. All of this is happening at the same time as the waters are stratifying. So the nutrient availability in the photic zone, which is where light is available for photosynthesis in the surface of the ocean, also decreases. So suddenly fish have high metabolic rates. They need a lot of food. There isn't much food. And the microorganisms that might cause disease are just going like gangbusters. So this is a perfect storm of conditions where you have basically starving fish that are immunocompromised because of the lack of food, that are being infected at higher rates by these microorganisms that are more pathogenic than normal because of warmer water temperatures. So in 2015, 2016 in the Galapagos, we had one of the strongest El Nino events in recorded history. That event sparked what we know now to be this ulcerative skin disease that affected at least 16 different species of fish in the Galapagos. And what I mean by ulcerative skin disease is these small patches of skin that start off looking almost like a patch of mold that starts to grow in a spherical shape, and then the scales start to fall off, and you get you get this exposure of the subcutaneous tissue. It's red. It's kind of leaching blood out into the water. It's really ugly. And those lesions grow and they combine, and eventually you can get most of the body of the fish has lost its scales and it's looking really bad. And they can lose the ability to swim if it affects their fins. So it's a really ugly disease that fortunately disappeared as soon as that El Nino event subsided and the waters resumed back to their normal cooler temperatures. But certainly it's an issue that is becoming more common with warmer oceans, that we're seeing more of these wildlife disease outbreaks. And, a lot of ulcerative skin diseases are common in conditions where you get high densities of fish, and sort of stagnant water conditions. So places like aquaculture pens, even aquaria that aren't properly cleaned, you get these kinds of ulcerative skin diseases quite commonly. But in contrast, the Galapagos Islands are this oceanic island group that's 1,000 kilometers off the coast of mainland South America, really, really far from any sources of coastal contamination or pollution, really well mixed water, with a lot of wave action and currents. So certainly not the conditions that you would expect would generate this type of an ulcerative skin disease outbreak. But in this 2015-16 event, this El Nino, such an outbreak occurred, and in some species and in some places, the prevalence rates reached over 50%. That means over half of all of the fish in some islands showed these ulcerative skin lesions. So certainly it's something that we know is linked to these warm water events caused by El Nino, but the exact mechanism of that disease pathogenesis we still haven't figured out yet.
Yeah, it's definitely a challenge doing anything kind of with wild fisheries. So since you mentioned obviously and started talking about the Galapagos, maybe can you describe a little bit about what makes the Galapagos kind of so unique, biologically?
So tropical waters normally have this really strong thermocline, which means that the surface waters are very warm and there aren't many nutrients available in those warm surface waters for photosynthesis to occur. The Galapagos are located right on the equator. So that means that they have tropical solar radiation year round. They have all the light that you could possibly want. And in contrast to most other tropical seas, they don't have as much nutrient limitation. And the reason for this is that there's a couple of cold water currents that hit the Galapagos Islands. And it just happens to be that archipelago is located at the confluence of two of these cold water currents. One of them is called the Humboldt Current, which comes from Antarctica up the coast of Chile and Peru and then starts to diverge westward and hits the Galapagos Islands. There's also the Cromwell or equatorial undercurrent, which is a subsurface current that's traveling at about 300 feet depth across the Pacific from west to east. Now, when that current hits the Galapagos platform, it's pushed up to the surface and again brings cold, nutrient-rich water up to the surface where photosynthesis can occur. So you have the combination of tropical sunlight and really high levels of nutrients being delivered to the surface. And that fuels a unique, highly productive marine ecosystem, one of, if not the most productive ecosystems in all of the world's oceans. Another reason why the Galapagos are unique is that they have not really been inhabited for that long. There's only been permanent human habitation of the islands for about 100 years. And for most of that time, there weren't many people moving to the Galapagos because there weren't many services. There wasn't much water. It's a really difficult place to make a living. And then in the 50s, Ecuador declared the entire archipelago as a national park. And this was a really forward-thinking move by the Ecuadorian government because as a result, the Galapagos Islands are incredibly well preserved. 97% of the land area of the Galapagos are off-limits national park. You can't move there. You can't cut down forest. You can't have agriculture there. And so only 3% of the land area is available for cities to grow, for agriculture to take place, for industry to have its home. And that's really limited the growth of the population in the Galapagos. All that has translated into minimal effects of humans on the marine environment. So it's still a place that you can go and see, large sharks, large grouper, large snapper. If you go for a snorkel or a scuba dive anywhere in the Galapagos, you will see all of these things. And in contrast, much of the rest of the world's oceans and coastal reefs are fished of many of these large predators because they are the most attractive for recreational and commercial fisheries. So we have a really intact marine ecosystem that's fueled by one of the most productive combinations of nutrients and solar radiation in the entire world.
Yeah, definitely a beautiful place. Appreciated your having me work with you there. let's shift a little bit back to the U.S. and North America. You had a chance to do some work in the Gulf of Maine, and we had the opportunity to watch you and John and some of your other colleagues on the relatively recent PBS series, Sea Change: Peril in the Gulf of Maine, when we were over in the Galapagos. So how did you get involved in that work in the first place, and what was kind of the goal of the research there?
Yeah, so Cassius Ledge is a seamount right in the middle of the Gulf of Maine. It's about 80 miles east of Portsmouth, New Hampshire. And much of the Gulf of Maine is a sediment bed, and it's the outflow of the Appalachian Mountains as they've been eroded over millennia by glaciers and rainfall. All of that rock and mud has been piling up in the Gulf of Maine. And so it's this really productive but sedimented, that means like a soft bottom area that's relatively shallow at about 250 feet deep. Now, Cassius Ledge is a rocky seamount that sticks up from this surrounding soft bottom habitat. And there's a major difference between hard and soft habitats in the ocean. Hard structures, things like rock or coral, are places where both plants and animals can attach themselves and grow. And there's a lot of organisms, things like kelp, things like corals, things like barnacles, that require a hard substrate to attach to in order to grow. Other things require sediment, then they burrow down into sediment and live in sediment habitats. But the fact that Cassius Ledge exists in the middle of this sedimented habitat means that there's suddenly this rocky, hard substrate for things to attach to. It also comes up to about 40 feet deep below the surface. So it doesn't actually break the surface. That's why it's a sea mount and not an island. But it comes to pretty close to the surface, which means that things like algae and kelp can grow on this rocky platform and take advantage of light coming down from the sun. So Cassius Ledge, as a result, supports one of the largest and most productive kelp forests in the entire Gulf of Maine. These beautiful laminarian kelps, Laminaria digitata and Laminaria longicruris. These kelps reach up to 15 feet in length, and they do form a canopy. So you can be hunkered down at the base of these kelp fronds and look up and see them swaying back and forth over your head. Cassius Ledge also supports one of the last healthy cod populations remaining in the Gulf of Maine. And the fact that it supports these healthy cod populations suggests that Cassius Ledge could be a refuge for cod, and that those individuals living at Cassius Ledge could actually seed other places in the Gulf of Maine that have been overfished and fished completely out of cod. So my PhD advisor, John Whitman at Brown University, has been working at Cassius Ledge and in the Gulf of Maine since the 70s. I was brought into working there by him in 2014 when we embarked on an effort to describe why Cassius Ledge scientifically, from a scientific perspective, how is it ecologically important? What is unique about it? How does it compare to the rest of the Gulf of Maine? And should we be considering protecting Cassius Ledge as some form of marine reserve in order to protect these unique kelp forest and cod populations that we know that it supports? So we started doing these surveys in 2014, comparing Cassius Ledge to other parts of the Gulf of Maine. And we've continued that work today to look at not only how does Cassius Ledge compare to other parts in the same region, but how has it changed? How has it changed since the 70s and 80s when John Whitman was first working there until now? And also, how has it changed since 2014 until now? Because this last decade has seen some of the rapid warming that we know that climate change is responsible for, and the Gulf of Maine is one of the fastest warming bodies of water in the entire world's oceans. So this effort is, scientific at its heart. We are trying to describe this unique place, what makes it unique, some of the processes that help sustain it. And then we're also working on the legislative side. So we're working with a variety of lawmakers, nonprofit organizations, and local stakeholders to actually gain protections for Cassius Ledge as this sanctuary, as one of these last holdouts of a healthy ecosystem in the Gulf of Maine.
That's great, and you had a really colorful cap, I have to mention, for the folks that haven't seen it yet, but definitely encourage our listeners to watch it. So yeah, how was it working with the PBS crew?
Well, it was kind of funny, I gotta say. We didn't really know what to expect when we headed out there. They were great people, really friendly, really curious, and genuinely interested in the work that we were doing. But it was also kind of silly. You'd go through 20, 30 minutes of getting all your scuba gear on and checking and double checking everything, and then getting your gear, and you're about to jump in the water, and then a cameraman comes up and says, hey, that was really great. Can you do all that again, but let me film it? And so then you'd have to take off all your setup and your 40 pounds of scuba gear, but in the end, it was obviously worth it. They got a great product out of it. I highly recommend that you guys check out the documentary. It's free. It's on PBS. It's also on YouTube. Just look up "Peril in the Gulf of Maine" or "Sea Change Gulf of Maine," and again, it's on PBS and Nova. But it was also quite something to work with the underwater filmographers. These are professional videographers that do work for documentaries and things, and they have these ultra high speed cameras. They also use rebreather systems, which means that you don't exhale bubbles and it recirculates the air back into your system, and that allows them to get really close up shots of fish and other organisms that might otherwise be scared off by bubbles. So the footage in this documentary is really spectacular, and I think it really conveys the magic of what it feels like to be down there on Cassius Ledge on this kelp forest.
Thanks. And yeah, although Sea Change was the title of the series, I think that's kind of appropriate for what's happening all over the place. Can you maybe give us a brief perspective on how you think things are going overall, and maybe what you think can be done or is being done to try to maybe mitigate or stabilize some of these systems?
Yeah, we know that we're changing things at an ever faster rate and in so many different ways. I just talked about temperature change, but there's all these other things that humans are doing, things like overfishing, pollution. We're changing the pH of the oceans and making them more acidic. And all these things, while they have happened in the past over longer timescales and due to natural reasons, we're making all of these changes go a lot faster, and they're so fast that they're faster than the capacity of organisms to evolve to adapt to these new conditions. So I think we're really facing some catastrophic change in the very near future, and we've already seen some catastrophic change. But at the same time, we've seen all kinds of new adaptations by humans to try to make things better for us and for the wildlife that we rely on. So, for instance, aquaculture, the production of fish food for humans, as opposed to extractive fisheries that are simply going out there and catching wild animals. Aquaculture production surpassed wild-caught fisheries in 2014, and that trend will never reverse again. So from now on, aquaculture will produce more food for humans than wild-caught fisheries forever. And that's actually a good thing. That means that we're actually starting to take more responsibility for the production of seafood as opposed to simply going out there and taking what's there. Also, I see a lot of hope in places like the Galapagos, places where I see school children that are, 5, 10 years old walking to school with backpacks where they've made a little drawing of a hammerhead shark or or a manta ray, and you see murals decorating the walls all along the road saying, let's take care of our oceans, let's take care of our resources. So there are places in the world where people are actively working to make solutions and generate a different mentality with regard to our natural resources, one of stewardship, not one of extraction. So I do see a lot of hope for the future, especially in our youth and these new movements to place more value on intact ecosystems. Also, from a scientific perspective, we're starting to understand a lot more about what makes ecosystems tick, what's required for a healthy ecosystem, how can we utilize things like living shorelines, so the use of organic materials like mangroves that are growing along shorelines, as opposed to simply putting a concrete barrier there to protect things from storms. So we're starting to learn ways to work with nature as opposed to against nature to address issues that are affecting all of us, things like coastal erosion and storm impacts. So I do see a lot of hope for the future in these new initiatives as well.
Well, that's good to hear. Unfortunately, we're out of time, but I definitely want to thank our guest, Dr. Robbie Lamb, and our producer, Mark Winter, for making the show possible. So, Robbie, any final words of wisdom for anyone interested in studying marine life and or who wants to help push things in the right direction?
Well, please stick with it. We need you. We need good people working on solutions. We need good scientists trying to better our understanding of how the world works. We need advocates for our oceans. We need storytellers and communicators. We need people out there doing positive stories, not just negative stories, but where are we finding victories? Where are we seeing change in the right way? We really need to highlight those stories because you can only get so far with these stories of doom and gloom. So I always like to end things on a positive note and just say that I see a lot of potential for improving the way that we interact with our oceans and with our natural resources. And I really thank you as well, Roy, for having me on your show and for having this podcast in the first place, which I think has really reached a large audience of folks that are that much better informed about marine issues and aquarium issues. So thank you, and thank you again for having me.
No problem. A pleasure. Please be sure to check out Robbie's web links, which will be found on his Aquariumania episode page. If you have any questions, comments, or ideas for a show, email me at drroy@petliferadio.com. That's DRROY@petliferadio.com. Until next time, please visit your local aquarium stores and keep your tanks clean and your fish healthy, and do your part to help restore and foster our marine ecosystem's diversity and beauty for both the health of our planet and for future generations.
Let's Talk Pets, every week on demand, only on PetLifeRadio.com.